most important. Grades for this class are due on August 19th. Uh, if you do not want a grade deferred, which I can do if people need them, if anybody feels like they need extra time, you would then have until October 15th. But if you don't want that, the very latest I can accept stuff would be 10 a.m. on the 19th. I do have the due date for your final assignment to be due at midnight, essentially on the 18th/19th, but I do know many of you turn things in advance of that. I will go over what is expected for that this evening. If things are late, don't worry about that. I do set deadlines so that ideally you're not doing everything all together at once, but you are working professionals, and I understand that the deadlines don't always work with the reality of your schedule. So if you're worried about turning stuff in, just turn it in. The last thing I will say is you should have gotten the link for the course evals. The one thing that I would ask you to consider, because I have been pushing this for years, I know for some of you this would be difficult, but if any of you feel like you would like a hybrid option or you think a hybrid option would make sense for quant, I would indicate that in the forums, or if you think some sort of informal meetup, if that is possible for people geographically, around quant would be helpful because sometimes it just is easier to go over statistics and work through these things when you are physically in the space together. That is definitely the forum to express that because one of the things institutional effectiveness who conducts the course evals does is, in the interest of methodology, they do keyword searches on course evals. And so if hybrid or in person appears more than one time, especially in a doctoral course where the numbers of the enrollment numbers are so small, institutional effectiveness in turn sends a report to the dean that's like, this might be something worth considering. Um, and also on that note, if anybody feels like after tonight they still need some extra help, want to go over things, want to set up something with me, happy to do that as well. Tonight we are going to talk through means comparisons. We're going to talk a little bit about generating visuals, an analysis of variance, which is another form of means comparison, and an entry point for regression analysis. We are not going to, as it is not a part of this course, we're not going to go through how to run regression. But if there is time, I would like to just walk through how to understand regression results, because as you guys continue to build out your literature reviews for chapter 2, and for those of you who may be going down a mixed methods or quant path, the value of the articles and the studies that use regression really is lost if you can't really engage with the numbers in the tables. So we will kind of go through a little bit of a cheat sheet on that process. With that said, does anybody have any questions before we begin? Okay. Sweet. And for those of you camera off, please turn them on as soon as you can. All right.
Um,
Yeah.
there,
Question?
not a question, just FYI. I'm not supposed to be sitting upright for upwards of 20 minutes. So I may
Okay.
I may stand up and walk
Yeah.
away
Or
for a
lay
bit.
down, whatever you
Yeah.
need to do, Verna. Whatever you
Okay.
need to do, girl. Yeah.
Okay.
Are we heavily medicated tonight?
I am actually minimally medicated.
Minimally medicated. Okay.
Yes.
But Alan Christian heard this. Just full disclosure, I have streps and I have lots of things here to help my voice. I'm hoping it holds out.
Hmm.
But we will see what happens. These things happen. But yes, Verna, please, 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 whatever you need to do to be comfortable. All right. Here we go. All right, so we're gonna start with means comparisons. I will say this. I have said many times in this class that you can do a quantitative dissertation that is purely descriptive, and that is absolutely true. That doesn't simply mean, though, that your findings only include saying the mean of this variable is this and the mean of this variable is that. A descriptive dissertation would also include a means comparison or would also include correlational analysis. Okay, there are two general approaches to means comparisons. The first involves essentially a two-group comparison, which has different versions of it, which we'll talk about in a second. The other version involves comparing means across three or more groups. So let's start with the two groups, so to speak. So the simplest form of a means comparison is when you are literally comparing the average of a group's score, for example, so data you've collected on something, to a specified value, right? So perhaps you want to see how representative your sample is versus the population from which you pulled it. You would compare the average GPA of the sample of students you have to the average GPA of all high school students in New York State. This is literally a test that allows you to compare the mean of the data you have to some other mean that has already been calculated that you're pulling from somewhere else. It could be a group score at a different point in time. It could literally be the national average, right? Does the mean GPA or the mean graduation rate in the NLSY actually approximate that of the national sample? In this instance, the steps in SPSS are literally calculating the mean of the data you have and comparing it to a mean value you enter, right? This is usually done when you are justifying the sample you have, or if you are trying to establish that the sample you have is performing better or worse or the same as something. Um, this is called a specified value or a one sample t-test. Okay. The next type would be if you are doing a group score of one group score on X to the same group score on X at a different point in time. Or one score at one point in time to another score. These would be data that you have collected, right? This is not taking an already determined value, like the mean income in New York State versus the mean income in your sample. This would be the mean income of the males in your sample, perhaps to the females, or the mean income of the males in your sample in the first year that they were employed versus the 10th year. Okay. This could also be thought of as a pre and a post test. This type of means comparison is either called a dependent sample t-test or a dependent sample or a paired sample t-test, or it's called an independent one. So the dependent one is when the sample itself is the same group across both points in time. So a pre and post test. If I had given you all five, six, seven of you a little bit of a statistics quiz before we had our first session, and I wanted to come give you that quiz again today after class. If I was comparing your pre, we started the class score, to your post, you took the class score, that would be called a dependent or paired sample t-test. Okay, so this is when the group itself is the same. The other approaches I mentioned would be when the groups are different, right? So when you're comparing the average of one group score to another group score. This is called an independent sample t-test. In other words, the samples are independent of each other. There's no overlap. If I wanted to compare your average grade in Intro to Quant to last summer's average grade to Intro to Quant, right? This would also work and is often employed when you're looking at an experimental or a quasi-experimental design. If you have a control group that doesn't receive some sort of service, intervention, or exposure to something, and then you have an experimental group that does receive the service, the intervention, or the exposure to something. Those, again, are two samples that don't have any overlap with each other, the control group of students and the experimental group of students. The independent sample t-test and the dependent or paired samples t-tests are the most commonly invoked. Okay, so again, the idea here is that you are trying to compare one group's score to another group's score. It could be another group, it could be the same group at a different point in time, it could be a totally different group. When you do compare these two scores to each other, you generate what we call a t statistic. And it is the ratio of the difference between the two groups, the ratio in the difference of the mean of the two groups relative to the standard deviation in those groups. Okay. Nobody will ever ask you to manually calculate this. SPSS can calculate this for you using the drop-down menus. You could also write a script in Excel to do this. So as long as you understand that the t-statistic is comparing the means of two groups relative to the variation in those groups, you get what a t-test is. The larger the t-statistic, the stronger the distance. In other words, the farther away from one, right? Because if the two groups are similar to each other in mean and in standard deviation, then the ratio will be, if it's identical, the ratio would be one. If it's very close, the ratio will be very close to one. A similar statistic to a t-stat is also an f-stat. It's computed using similar means. The f-stat, though, is the only statistic that's generated when you're comparing more than three groups. It does get generated for a two-group comparison, but you only want to report the t-stat for the two groups. Before we move on, who needs some clarity on that? I just threw a lot at you. Hi, Rhonda. Okay. What's confusing? What do we want to go back to?
I don't know if I'm confused. I guess just trying it out would probably be the best way for me to understand, but
Okay, so let's put it in the context of data you might collect. Okay.
okay.
Let's say that you eventually get land grant institution information for HBCUs and tribal colleges, and you want to compare federal funding allotted to each of those two groups and how those two groups compare. So across and I did look at these numbers with you recently, but I'm blanking. I think there's 17 tribal colleges that are land grant institutions because they're all land grant institutions. And I forget the HBCU group, but let's say for ease here, let's say the federal allocation for the tribal colleges was $1 million a year and the federal allocation for the HBCUs was $5 million a year. The means comparison for that would be an independent sample t-test because the group that informs the tribal colleges average has no overlap with the group that informs the HBCU average, right? The institutions are distinct. And the t-test would basically compute a ratio of the average allotment and the standard of each school and relative to the variation or the standard deviation. Remember, the standard deviation tells you how far the data spreads from the mean. So when you have a big standard deviation, what does that mean about the range of your data?
Your range is going to be large.
Range is going to be large, yeah, right? Not a bell curve, not normally distributed. Probably got some outliers. When the standard deviation is rather small, it means that the majority of the data is relatively close to the mean. The distribution is fairly normal, okay? So I would suspect in the tribal colleges that there is not a great deal of variation. They don't get a ton of money. They don't get as much money as they need. But I would suspect at HBCUs, because they vary greatly in enrollment size, that there is quite a bit of variation. And so the standard deviation might be larger in that group. So when you compare those two with each other, you probably get a decent sized T statistic, which tells you that not only is the HBCU allotment greater, but that you can have a degree of statistical confidence that if you were to randomly select one HBCU and randomly select one tribal college, that that pattern would persist. That that random HBCU you select and that random tribal college, the HBCU would have more money. You're muted, Rhonda.
The comparison has to be between those two groups. It can't be all the initial land grant institutions, the HBCUs, and the tribal colleges. You have to do two groups.
If you're doing three groups, it's an ANOVA, which we'll get to in about an hour.
Okay.
Okay. If it's
Okay.
two groups, it's a T-test.
Okay.
T2. That's how I remembered it when I first learned this. Okay. If it's three or more groups, you can absolutely conduct a means comparison. It's just a different type of modeling.
Okay. Gotcha.
Yeah. It's probably been a while, Melissa. Other questions, or should we put this? We are going to use an example too, but are we starting to get it? So again, the two groups can be completely independent of each other and distinct. You guys are higher ed 7? Is that right? 10. Sorry. All right. Higher ed 10 versus higher ed 7. Or, and this wouldn't be such a great comparison because your numbers are small, or it could be higher ed 10 males versus higher ed 10 females. Those are independent. There's no overlap in those two groups. Or it could be higher ed 10's knowledge of X when they came into the program and higher ed 10's knowledge of X when they left the program. In that case, the two samples are dependent on each other or paired because it's the same people. Okay? Does that help? Okay, other questions before we proceed? Okay, let us return. Portion of screen. Here we go. All right. So, let me walk through the steps. If people want to open the program at home, they can. But for the first one, you don't need to have it open yet because this is just the one sample means comparison. So if you want to do that one sample t-test, you want to compare in the NLSY the average score on this variable to whatever the national average is. You go to Analyze, Compare Means, okay? And then you go to One Sample T-Test. Now, in the One Sample T-Test, remember, you are comparing data that you have. Either you collected it because you sent out a survey you created, or you got the data from somewhere to a set specific value, okay? So you select One Sample T-Test. There is a space for a test variable. You can put more than one, and then a test value. Here is where you would enter the average score on whatever the variable is, right? So the average SAT math score for the year from which this data came from was 523. We are comparing the SAT math variable from that NLSY. Okay, you would click OK. All right. You will get a one sample t-test. The top box just gives you that basic descriptive on that variable. The sample size for that variable is what?
1,407.
Yep. The average on that variable is what? What's the average of the SAT math score in the data set?
500.
500.6 essentially, right? What's the standard deviation?
115.
Yeah. Okay. That's just pure descriptives. If you were doing a study and using SAT math in your table 1, right? You would have the mean and the standard deviation. What you ran the test to discover is when comparing that 500.59 to the 523, are they statistically significantly different? So the first thing you should look at is the T statistic, which is in the one sample test box. What is the T statistic? It's labeled T.
Negative 7.3.
Yep. Why do you think it's negative, guys? What's the national average that we put in?
523.
What's the average in the sample in the data set?
500.5.
Why is the T statistic negative?
Because it's less.
Because it's less. Yeah. If your variables, if the data you have score is greater than the data than what you're comparing it to, the T statistic would be positive. Okay. So the T statistic is minus 7.3. Okay, that's not one. That's not necessarily close to one. Let's see if it's statistically significant. Let's look at our significance. So we're going to look at the two-sided P. Okay. What is the P value?
Less than 0.001.
So does that mean that the T statistic is statistically significant or isn't statistically significant?
It is.
It is. Okay. So if you were writing up a descriptive of your sample in the NLSY and you were talking about their average standardized achievement in that year, would you report that they, on average, scored lower on the SATs than the national average? Melissa says yes. Do we agree with her? Christian's nodding.
Wait, the question was, do they
Would
score
you
less?
report, let's say you were trying to establish whether or not your sample is comparable to the whole population of SAT takers. Would you report that your sample on average has scores lower than the total population who scored?
No,
Why not?
I thought the difference was less than 0.001.
That's not the difference. That's the statistical significance.
Oh,
The difference is actually, what's the main
oh,
difference
I see. Okay,
between the two values? It's in the table.
I see.
The main
Negative.
difference is 22.4 points, roughly, right?
Mhm.
With 99.9% confidence, you can report that your sample scored lower than the national average. And the reason why you can do that is because the T statistic shows you there is a difference because it's computed via a ratio, right? If things are the same or nearly the same, the ratio equals 1, right? If the average score on SAT math in this data set was 522, the ratio would be very close to 1. Okay. The T-stat is away from 1 and it is statistically significant based on the p-value. Remember, the statistic you compute gives you a sense of the things you're comparing. The p-value tells you if you can be confident that that is indicative of actual patterns in the data or if that is just randomly due to chance. Okay? It tells you the degree of confidence you could have that if you randomly pulled a row of data from the data set, that it would be lower than that national average of 523. Does that make sense? I feel like we're not saying anything because it doesn't make sense. What do we need help with, guys?
I think the P that's kind of tripping me up a little bit.
Okay.
I don't know why I was thinking about it as I don't know the difference.
So the p-value is the indicator of your statistical significance,
Hmm.
right?
Yep.
So for the purposes of research, you tend not to report things that are not statistically significant. It's a bias in what gets reported and published in academia. But this is what it is. Because the p-value literally tells you the degree of statistical confidence you can have in that result. Statistical significance gives you no sense of the degree of the difference. So, like, you could have a mean of an SAT average on math that is 800. Everybody in the group scored perfectly, right? And then you can also have against the 523, and you could still have the same level of statistical significance. It doesn't depend on the difference in what you're comparing. It depends on whether it's reflective of the data as a whole or whether there really are no patterns in the data.
Okay.
Okay?
Hmm.
So p-value is the name of the stat that measures statistical significance. The baseline p-value, as Melissa just put in the thing, is 0.05, which is a 95% confidence. So to be 95% confident that your outcome, the finding, the statistic is not due to chance, you need a p-value of 0.05 or less. To be 99% confident, you need a p-value of 0.01 or less. And to be 99.9% confident, you need a p-value of 0.001 or less. The p-values are simply like one representing 100%, right? Minus 95, minus 99, minus 99.9.
So a p-value of 0.05, even though it says 95% confident, would you feel comfortable with the
Mhm.
outcome of that? You still would? Okay.
Yes, I would say look, 99.9 is great, but I would say, especially in social science research, which is not highly controlled, which is not in a lab setting where you know all the ins and outs, is solid. Hard science, like biology, pharmacology studies of the effect of the drug on they don't report 95% confidence intervals
Mm.
because everything is so highly controlled, right? There are so many additional factors at play here. Think about this. Did you trip on the way in to take the test? Did you accidentally, it's all computerized now. Did you like hit the wrong button, right? When you're dealing with data collected in real world settings where there are a myriad of factors at play, right? 95% is great. In your dissertation work, 95% is perfectly fine.
Okay.
Yeah. Other questions? All right. Let's try to move to the next one, which would be paired sample t-tests. And this would be when you are comparing one group score on something to the same group's score on something else, right? The change could be time. It could be like a pre-test, post-test scenario, or it could be um, kind of after an intervention, that kind of thing. Again, analyze, compare means. This is where all your means comparisons are. Paired samples t-tests. Usually in a data set, you would have like a pre-test variable and a post-test variable, or you would have a time one variable and a time two variable, right? Or if you were annually collecting satisfaction with a program or job satisfaction, you would have job satisfaction year one, job satisfaction year two. You put the two variables in, you click OK. Tables look a little bit different. You're still looking for your T statistic. Okay? In this case, comparing the pre to the post, the mean difference is minus 12.146. Now, think back to this first set, okay? The mean difference was also negative comparing the NLSY's average math score to the nation's because the NLSY sample score was lower. So looking to this one then, right? The mean difference is negative, which means which score was higher, the pre or the post? So the pre-test minus the post-test is minus 12.146. Which score is higher, the pre-test score or the post-test score? What do you think? If you subtract two numbers and the answer is negative, which one is higher, the first number or the second number? If you got $100 in your bank account and then you go and write a check for $120, how much money is left in your bank account?
Is it the second number? Or
The second number is higher or lower?
higher?
Yeah, right? If you have $100 in your bank account and you go and write a check for 120, what's in your bank account? Somebody answer me, please.
Negative 20.
Thank you, right? The second number is higher. Now, you're screwed in that case, right? The post-test score, therefore, was higher. Now, in comparing them, let's look at that T-stat. What do we think? The ratio of difference is non-existent, close to one, very small, or big?
Large.
What's the T-stat?
Negative 129.
Yeah, is that small? Is that close to
No.
one, Rhonda? No,
No.
that's big. Okay. We got a large T-stat, meaning that the ratio of difference in the two groups and their distribution is big. Okay, but is that random? Are there some outliers in this data, or is that reflective of overall patterns in the data, overall trends in the data? What would I look to answer that question? So I know there's a difference, and I know the ratio of difference is fairly large. What would I look to see if I can actually report this difference in my dissertation? Which statistic? Ooh, broke. Yes, Melissa broke.
Hmm. Um, I'm not sure if it's the one-sided or two-sided or if there's
It's the one-sided If there is a difference in the one-sided versus the two-sided, it means that the SPSS has dropped extreme outliers, but as long as they're the same, it means it's including all of the data in the data set. So either one, they're the same. Is this difference statistically significant? If you're studying the effect of a after-school tutoring program on a group of kids, you look at their test scores before they have the tutoring program come, and you compare them to their test scores after the tutoring program comes. The comparison of the scores yields a t-stat of minus 129.33 and a significance level of 0.000. Could you report that the tutoring program works?
Yes.
Yes, because why?
Because it's significant given the value. So the way I'm interpreting it is I put it in the chat. Wouldn't it be 100% if you're looking at it
Yes,
from one minus the
which
decimal?
would mean every row in the data set, every student in the data set's post-test score was higher than their pre-test score. 100% confidence means you can be 100% confident no matter which row of data you selected that the trend would be this, that the post-test would be greater than the pre-test. Okay? If it's lower than 100%, it means that some of the rows in that data set don't follow this trend. It doesn't mean you can't report the trend. It just means that you can't be 100% confident. So if you were trying to measure the impact of this tutoring program, you would report that it works. Okay? Students who participated in it, on average, scored higher after their participation. Questions on this?
Yes. Did you go over the standardizer?
No,
No. Okay.
I haven't gone over effect size yet. Effect sizes give you a similar statistic and sense of the data, but you use them when you have small sample sizes. SPSS will compute effect sizes on really large samples, right? But if you have a large enough sample, you can feel confident in the T outcomes and they are robust enough. But if you have really small samples, the effect size, like less than 20 or less, effect size is what you want to look to. Okay. And the effect size tells you how large the effect, in this case, time, the intervention, whatever, because it's a pre and a post, is on the outcomes. It's rare, though, that in like a dissertation study context that you would have such small groups. Because if you were collecting your data and you only ended up with that many, I would tell you to keep going.
Wait, so are effect sizes only attached to when you're comparing like a pre and
Very,
post assessment?
no, you can compare variables to each other and compute two groups, two variables,
Okay.
right? They are more valid. It's a more valid statistic when the sample size is small. It basically tells you the relationship between things rather than how confident you can be that the intervention time, whatever, is generating change. There is some sort of relationship between the two. Something is at play here, right? If you are generating an effect size relative to a pre-test and a post-test, and it's greater than one, you can report that something is happening between the pre and the post, but you cannot report with a degree of statistical significance. So there's no confidence. SPSS, all kind of statistical programs don't like to compute statistical significance when there's really, really small numbers. Because one data point could skew the whole thing.
Thank you.
Questions? Okay, should we keep going or do we need to keep reviewing? I need some sort of feedback. Liliana says go. Okay. Melissa's hands are floating. Great. Thank you guys. All right. So that was a paired sample t-test, remember? Right? That's when the groups are dependent on each other. The last time type of t-test, sorry, would be when the groups are what of each other? Dependent? No. So what is the opposite of dependent?
Independent.
Independent, thank you. The two groups you are comparing to each other have no overlap. If you're looking at students, it's not the same students. Okay? If you're looking at universities, they're not the same universities. If you're looking at school districts, they're not the same school districts. Okay? All right. Let us go back to the videotape, as someone used to say. All right. So now we're going analyze, compare means, independent samples t-tests. So again, your control group versus your experimental group, non-white versus white, male versus female. Okay. You go analyze, compare means, independent samples t-test. Up pops your dialog box. Let's now look at comparing SAT verbal and let's compare it based on the sex gender variable. So for an independent samples t-tests, you need two variables. You need the variable whose mean you want to compare, and you need the grouping variable. The grouping variable is what defines the two groups that are independent of each other. Okay? Now, you would move that variable in, and then you would select define groups, and then you would tell it the specified values you want to include. The reason why you have to define groups is you could have a grouping variable that has more than two groups, but let's say you didn't want to create a new variable in the data set. Let's say you had a variable for race ethnicity, but you really only wanted to compare white versus Hispanic. But the variable itself also included African American, Asian American, et cetera, et cetera. Then you would just go in and say, I only want you to create two independent groups based on these values. So you would put in the grouping variables, which essentially reflect the codes for the two groups you're interested in. Once you do that, instead of having the question marks here, it has the two groups. And then you would click OK. All right. So let's look at our top box here first. What is the average male SAT verbal score in the sample?
503.
Great. What is the average female score SAT verbal in the sample?
497.
Great. Now, 503 minus 497 is a difference, right? If I was trying to assess whether boys are better ELA students and I was using SAT verbal scores as the metric, would I report that boys are smarter? Melissa says no. Al says no. What do we think, Liliana, Rhonda?
Is it because one doesn't have to do with the other? Or sort of?
No, because you're comparing them to each other. One doesn't have to do with each other. That's why it's independent samples. So we looked at the means. Let's start with here, Liliana. We looked at the group stats. We looked at the mean of each group. What's the next statistic on this output page you would look at?
Is it the significance?
So the significance is a piece of it. Yeah. What are you seeing there?
Um, Is it the 0.544?
That's the F-stat significance, but I would look at the T-stat significance, one-sided, two-sided, but both of them tell you the same thing. Is the difference statistically significant,
Oh,
Liliana?
so no then.
No, exactly. And what's the T-stat, Rhonda?
It's point point nine 15.
Yeah, 0.92 essentially, right? Is that tiny? Is that close to one?
Oh yeah, it is.
Yeah. The difference here is negligible. You could not report that. In comparing the average and the variation in the male group to the female group, not only is there a very small amount of difference, it is not statistically significant.
Mm.
So, Liliana, everything you said was right. I would just reverse the order. I would first go to the T stat because that's telling me the ratio of difference. And then the significance is telling you whether or not that is due to chance or due to patterns and trends in the data. Again, you can have statistical significance on a really small t stat. Okay. You can have no statistical significance on a really large t-stat. The significance has no bearing on the size of the difference, on the size of the impact, on the size of the effect. The statistical significance simply just tells you if that statistic represents the data as a whole. Okay.
Okay. That's good to know because I was going to ask for our purposes for our dissertation, should we just choose a small sample to whatever?
Well, if you're gonna do quant, I'm gonna push you to have as large a sample as you possibly can.
Okay.
Okay. However, in your case, Rhonda, if you're gonna include, for example, tribal colleges, the finite population isn't that big, right? So in that
Right.
case, I wouldn't suggest you do a subsample. I would say get the data on all of them. Okay. Now, the total number of land grant institutions in the United States that are not tribal colleges and not HBCUs, large. So
Right.
for that, I would say you could pick a random subsample. But,
Okay.
right. But I say that to make this point. You can still conduct a quant study when the numbers are small, especially if if that's the population. If the population itself is small, I cannot literally expect you to get a sample size that's greater than 100, right? There
Hmm.
are In that case, if you were comparing those I would say effect size is how we're going to go. We can see if there's a relationship of difference here. We're just not going to compute statistical significance about it, right? But the T-stat being small or large has nothing to do with the size of the groups. It has to do with the magnitude of difference. You could get the same T-stat. You could get a T-stat that's 2 point something on a sample of 1,000 people. You could get the same T-stat on a sample of 25 people. It
Mm.
would just mean that on average, that data is looking different in a similar way, right? And the statistical significance is all it's telling you again is whether or not you can report it with a degree of confidence.
Mm.
Okay. So this is a quant methods class. I'm gonna push you got like we gotta focus on degrees of confidence intervals here, right? Now, there is validity in substantive significance, especially if you have a small sample size. And all that means is that you're reporting the data as is, and you're not reporting a degree of statistical confidence. I do not teach the qual class. They don't let me do that. And full disclosure, I do qual only in tandem with other people. I need like Dr. Wepner to hold my hand. I've never, since grad school, I haven't done a qual study on my own. But in quant, it is valid to report what we call null results, right? I've asked you guys like what's the research hypothesis that there is a relationship between something that something will change, and the null hypothesis is that there's no relationship, nothing will change. There is a bias in academia to only focus on statistical significance. That doesn't mean that it's not informative and valid to report the other stuff. And sometimes it's necessary. I had a student 4 years ago who was trying to study the impact of the this program called Teach for Tomorrow in the state of Virginia, wherein high school students could enroll in undergraduate education courses to work towards getting their certification and their bachelor's in education. And the idea was to hopefully encourage more people to go into the profession of teaching. And he wanted to see if the program itself changed their perceptions of the profession. He didn't get a large enough sample size to get statistical significance. He only got like 60 some odd students. And when you started comparing like males to females and different racial groups, the numbers get even smaller. He still finished his dissertation and defended it, right? And he wrote about the substantive significance, right? For this group of students, it did change their perception, but for most students, it didn't. And his big conclusion was that, like, it wasn't that the program wasn't working, it was that people who were already interested in the profession self selected into Teach for Tomorrow. They were like, I want to become a teacher. Why not take some of these classes for free and then either get to take other classes in college or take less time to get through college, right? But I know I want to be a teacher, so I look favorably upon this profession. That's totally valid. It's just less likely to be published, which is bias in academic publishing, full disclosure. Because it also means that then there's a bias for like giant sample size studies, which tend to take longer, which tend to take more resources, which means faculty at giant research one institution, like, we could talk about it, it trickles down. Okay, first question is, are we comfortable discussing what statistical significance is? Yes. Liliana, you feel good? Rhonda, how do you feel? Verna? Remember, it's just telling you how confident you can be that that result is reflective of patterns in the data. Okay? Versus random. And the randomness usually either comes from outliers that may be influencing things or really small sample sizes, so you can't be sure. Because remember, all of SPSS statistics, all it is it's an iterative process, right? It's comparing male scores to female scores. So it looks at row one in your NLSY data set. And is that a male? Is that a female? Okay, that's a female. Let's find the next male score. Let's compare it to that. Now let's compare that row one female to the next male. And it goes through all those iterations of processing the data until the trends that it's producing stop differing from each other. Okay? If you're looking at like the correlation or the association between how much you earn and your job satisfaction, which some of you did for the lab, right? It basically said row one of data. How much do they earn? What's their job satisfaction? What's the correlation? So Liliana's job satisfaction score is this and her income is this. Okay, next, Nora. Job satisfaction, income. Rhonda, job satisfaction, income. Melissa, Verna, Christian, etc., right? And when it gets to a point where the relationship between those two variables at the individual row level doesn't change the overall average, then it spits out the statistic. That's literally how this process works for correlations, means comparisons, effect sizes, regression models, anything predictive. Anything that is purely descriptive of one variable, right? What does the income look like on average in the data set? There's no iterations there. It's just summing all the rows and then dividing by the total. Does that make sense? Okay. So we're comfortable with statistical significance. Are we comfortable with what a t-stat is? Without telling me like what defining the t-stat, can somebody tell me, maybe not Melissa, when I would compute a t-statistic? What am I trying to look at? What am I trying to assess when I would compute a t-statistic?
In the early stage of basically trying to find out your targeted group versus your non-targeted group, if that makes sense. Made sense in my head. I don't know if that actually made
It could
sense
be
out
your
loud.
targeted group versus your non-targeted group. Targeted. Are those two groups related to each other at all?
In a way they have, yeah, in a way I would say that they should be, yeah.
They could be. I'm going to
Yeah.
correct you. They could be, in which
hmm
case, is it dependent or independent, Christian?
What do you mean? Like
If
it's
the two
the
groups are somehow related to each other,
mhm.
is it a dependent samples t-test or an independent samples t-test?
If they're related, dependent.
Yes. Okay. Verna, try to give me an example of when you would do an independent samples t-test.
Oh. Um, I just want to make sure I have a proper understanding. So, T-stat is like you are measuring the difference between the two groups, right? Um, so like if I had test takers, men and women, and I want to measure the difference between how men perform versus the way women perform.
And are those two groups dependent on each other or independent of each
They're
other?
they're they're independent. They're two separate groups,
Yes.
but we're measuring their test taking skills or
Yeah,
the difference.
you're comparing the
Mhm.
means
Yeah.
on something of these two groups. Okay, now
Mhm.
Verna, if I was trying to compare Verna's pain level before surgery and after surgery, is that
The
independent or dependent?
dependent is they're both me.
Yes, they're both you.
Uh-huh.
That's all that it is.
Okay.
Okay. Rhonda, if I'm trying to compare land grant institution allocation during the Obama administration versus Orange Cheeto, what dependent or independent?
Dependent.
Dependent. Okay.
I was thinking about mine. I was thinking I'm comparing all three groups, wealth distribution. That would be independent though, wouldn't it?
Oh, three group. Well, it wouldn't be a t-test though, because it's three
Oh,
groups.
that's
Then
right.
we
I
move
keep going.
into ANOVA.
Let's just do the two then. The tribal and
Okay.
HBCUs. They would
Yeah.
still be independent though, right? Okay,
Yes.
just making sure.
Okay.
Gotcha.
Does that feel better?
Yes.
Okay. So do we now feel like with the help of the screenshots and this recording that we could in SPSS calculate paired or dependent samples t-tests, which are the same thing, or independent samples t-tests? Okay. And without, I'll put this stuff back up if you want, but let's try this. Let's say I do that. The output comes. What's the first thing I'm going to look at in a t-test? You want me to put the slide back up? Okay, no problem. I'm feeling good though, guys. I feel like we're getting somewhere. What's the first thing I'm looking at?
Is it the mean?
It's the two means. Absolutely. Yeah. Yes, Liliana. One, it gives you a general sense of what's going on here, right? And ideally, if you're already like in your dissertation data, you would have looked at those means earlier, right? But for the point of this exercise, yes, the first thing we're gonna look at is the mean. What's the second thing I'm gonna look at?
Significance?
The significance. And then what's next?
Is it the T?
Yeah, T and significance are kind of interchangeable, right? It's it's like, what are you itching to know? Are you itching to know magnitude of difference? Or are you itching to know if you're going to report it? And I suspect many of you are going to want to know. Al, you're going to want to know if you can report it based on what I know of you. Like, did I answer my question? Can I use this? Right? He's business. Personally, I like to first understand the magnitude of difference, but also I've been doing this a lot longer. All right, so you look at the means to get a sense of your groups. Then you look to your T-stat and your significance, either one first or together, to tell you what is the magnitude of that difference and can you report it with a degree of confidence. Okay, again, Liliana, can I report gender differences in SAT verbal scores with a degree of confidence?
Is it yes, because they're close and
Is there a gender difference in SAT scores? If my research question was, do male students score higher on SAT verbal than female? Can I answer that question with a degree of statistical confidence? Look at the significance.
that's the 0.544, right? The
It
significance?
could be that, or I will look at the T significance, which is the 0.18 and the 0.36.
8 and the 0.3.
Are those significant?
So no.
Yes.
Okay.
Okay. Now, that was great, Liliana. I'm going to say one more thing. I hope it doesn't confuse you.
Okay.
Let's see if people remember. Why is the one-tailed significance different than the two-tailed? Does anyone remember? Or let's start with this. In the spectrum of statistical significance, which one is getting closer to being able to be reported? Is it the one-sided or the two-sided? Which one's smaller?
One-sided.
Yes. Okay. When you have outliers in the data, your one-sided and your two-sided significant levels are not the same because it means that in the one-sided, it omits the outliers. So even omitting the extreme outliers, it's still not statistically significant. So if your two-sided was like really big, 0.36, but then all of a sudden your one-sided was 0.05, it would mean that there was like a very small number of outliers, and once you cut them out, there's patterns in the data. Okay? Now, Verna, if I'm comparing the tutoring program, pre-test, post-test, can I report that the tutoring program worked, that it improved test scores?
Yes.
Yes. And
Uh,
how do you know that? You're right.
why do I know?
P-values.
So what's our p-value?
Oh, oh, shit. Sorry. Excuse
That's
me.
okay.
Uh,
What's the p-value? One-sided or two-sided?
they're the same.
And it's what?
0.
0.000, right? And our
Yes.
t-stat is large and negative, meaning that the post-test was higher.
For all of them.
Yeah.
So there
So
was a
in
positive
every
change.
single
Yes,
row in
okay.
the data,
Yes, yes,
every
yes.
kid in that tutoring program, For every single kid in the tutoring program, their post-test was what relative to their pre-test?
Higher.
Yes. How do we feel about that now?
The white walkers are here. I'm sorry. I forgot my mic's on. Pardon me.
Oh, it's okay. Did you say the White Walkers are here?
It's in the chat. I didn't do it.
Oh, because that's what I heard. Oh, okay. I was like, what? All right. Now, one more time. Let's try this. Christian,
Yeah.
can you report that the SAT math score of the data you have is significantly lower than the national average?
Um, that it's significantly lower.
Mm-hmm.
I'm looking for the national.
So the national is the 523 that we put in, remember?
Okay. I would say yes then.
And why you're correct. And what is your evidence that leads you to that?
Well, if we look at the T is -7. If you look at the mean difference, the mean difference is -22, which is significantly more different.
And how do you
Uh,
know it's significantly? What'd you look at to get that?
because if you, I hate math with that, so I'm so sorry.
It's okay.
Um,
Do you see significance in this table?
it's a little blurry. Hold on. Oh, right there. Okay, yeah. So it's below 0.001.
Yes. Okay. Great. Do we feel
So
better?
yeah, yeah.
Okay. But this is the exact fundamental conception and conceptualization of this that you need when we move into ANOVA. Okay? It's a slightly different statistic because the formula has to be different because you are now comparing more than two groups. Okay? So it's not a simple ratio of group A to group B, right? Or group A at point one in time to group A at point two in time, or group A to a national average. But it's the same fundamental concept. You are comparing the averages of three or more groups to each other to see if they are different and if that difference is due to random chance or actual patterns in the data. Okay? So we're going to take a quick break on that. Okay? Okay. ANOVAs are for comparing more than two groups, so three or more. They also allow you to do more formal hypothesis testing. Okay. You can address a hypothesis with a t-test. However, the ANOVA takes the statistical comparison a step up and adds additional statistics, which allow you to be even more confident. Traditional hypothesis testing, as we talked about a little bit earlier, right? You generate a research hypothesis and a null hypothesis. If, in fact, you are going to do a quantitative methods or a mixed methods that includes quant dissertation, you will present in chapter 3, along with your research questions, a hypothesis and a null hypothesis for each question. Okay? So in chapter 3, you will reiterate your questions, and under each question, you will have your research hypothesis, which is referred to as H sub n, and then your null hypothesis, which is referred to as H sub 0. The n represents the total number of questions you have. If you have 3 research questions in a quant dissertation, you will have research hypothesis H1, H2, and H3. And for each one, you will say, I think there is a relationship between these two things. Going to this program leads to more success. Higher ed administrators who do this lead to this. Uh, Allocation of federal funding for land grant institutions leads to this. The null hypothesis is simply the absolute opposite. There's no relationship. It doesn't lead to anything. It doesn't impact or affect that. Okay? As I said, there's no significant difference between the specified populations. In the null hypothesis, basically any observed difference that there might be is due to sampling or experimental error. The point of hypothesis testing, which is what ultimately distinguishes quant from qual, is that you use your data and your data analysis to either reject or confirm your research hypothesis. So if in fact we yielded independent samples t-tests that had a t-test of 1.2 or a t-test of 101.2, but the statistical significance wasn't there, then we cannot confirm the research hypothesis. We have to reject it, and you can only confirm the null hypothesis, that there is no relationship, nothing is going on here. Okay? Now, sometimes you falsely reject or accept a hypothesis. This can be due to errors in data entry or sometimes due to errors in data analysis. If you falsely reject a hypothesis, it's called a type 2 error. And if you falsely accept a hypothesis, it's called a type 1 error, right? COVID tests experienced quite a bit of type 2 errors. There were a lot of COVID tests in the beginning that did not tell people they had COVID when they actually did because they had not yet improved the quality of the tests. So you were like, I'm fine, I'm kissing everybody, I'm going out into the world, and then you were a super spreader. Making a statistical decision when you are doing field work, real world data, always involves some level of uncertainty, right? That's why we are rarely 100% sure of things, right? The probability of making a type 1 error is essentially your significance level. So remember, a type 1 error is when you have a false positive, okay? So in a 95% confidence interval, the probability of a type 1 error is what? So you'd be 95% confident. What's the probability that you're wrong? Or the percent that you're wrong?
5%.
5%. In a 99% confidence interval situation, what 1%? Thank you, Liliana. In a 99.9%.
0.1.
Thank you. All right, guys. Do we get that? Okay. I'm feeling where we are right now. I'm feeling good about it, guys. I hope you are too. Okay. So let's go back to analysis of variance. All right. In real life, things don't always result in two groups being compared. T-tests can be problematic, right? Let me give you an example here. At the 0.05 significance level, right? So 95% confidence interval with 100 comparisons. That means that 5 of those 100 may show a difference if it doesn't exist. Do you see that? Now, 5 out of 100 is small, but it's still something, okay? So the more t-tests you run, the greater the risk you might have of this. The ANOVA allows you to see the differences between means with an omnibus test. And what I mean by that is, in the t-test, it just looks at the difference one group to the other. Whether that's distinct groups, the same group at different points, or a group to a statistic. It only looks at how those two things compare to each other. The ANOVA looks at how the groups compare to each other, but also looks at how the units within the groups compare to each other. Okay? So the t-test will look at, for example, males versus females. It will not account for whether or not the males have a great deal of variation. Okay? It will compare the average GPA of women as a 4.0 to the average GPA of men as a 3.5. It will not look at the men versus each other or the women versus each other. There could be a lot of variation within the groups. The ANOVA looks at the groups versus each other, but also the members or the units within the group to each other. Does that make sense?
Wait, can you say that one more time?
Mhm. The ANOVA is comparing two groups to each other and only looking at those two groups in terms of what drives the variation. Okay? So if the male GPA is lower and the female is higher, the t-test is only comparing whether or not the difference is driven by girls having better grades or girls being smarter. It's not looking at whether or not there's a couple boys with 1.0 GPAs. The ANOVA will both compare three groups to each other, the higher ed pathway to the signature pathway to the dissertation completion pathway, and are there differences there? But then it will also look within those groups to see if we were looking at, for example, time to graduation. The DCP students tend to have a they have a greater deal of variation because do you guys know what the dissertation completion pathway is? So it's ABD, all but dissertation students from previous programs who for whatever reason didn't finish. Some of them are starting right now and they left in the spring. Some of them are starting right now and they left 10 years ago. So some of them got all the way through coursework and even defended a dissertation proposal. And then life happened, they moved, their faculty advisor left, something, right? But it's all fresh in their mind. The project they were going to do there, they still do here, right? They don't need to take additional coursework versus somebody who I had a student graduate in the spring who left her doctoral program in 2001. So 25 years later, she came back.
Yeah, but a lot could happen in 25 years in
A
terms of
lot
the
happened in
research that
25
you.
years. Yeah. But also, like, you think she remembered research design? No,
No, yeah.
right? There is a great deal of variation in how long it takes DCP students to finish the program. So when comparing average time to degree, the DCP to the signature to the higher ed, there could be a lot of difference, and it could simply be because within the DCP, there's a ton of difference. The ANOVA takes that into account. So it does this additional level of check to confirm what's driving the differences. Does that make sense? Yeah? Okay. So let us go back to the slides. All right, so the ANOVA compares the variation between group means, signature, higher ed, DCP, to the variation within group means. So if it's really that the DCP are so different from each other, it'll tell you that. If the variation between the group means DCP versus higher ed versus signature is significantly larger than the DCP students versus themselves, you guys versus each other, and the signature students versus each other, it suggests a significant difference between the groups. Okay? Instead of a T-stat, you get an F statistic, which compares between group variability, between group difference to within group variability. Okay? Analysis of variance basically is like this. Comparing this on the right bell curve, nice bell curve, to in the middle, this more flat distribution, to then on the left, this spiky high distribution. It's comparing the three to each other. Which of these three distributions, represented by these three curves, has the greatest degree of variation? The one on the left, the tall one, the flat one in the middle, or the normalish one on the right? What do you guys think? Which has the most difference within the group?
Is it the one between the left and the right?
The middle one, yeah. It's spread out. The difference between the upper bound and the bottom bound is going to be greater. Which one has the least amount of variation?
The first one,
The first one, yeah. Why? How do you know that?
it has the lowest spread.
Yeah, it's squished.
Mhm.
Okay. Okay. In ANOVA, the data must be experimental or quasi-experimental. Okay. Yes, Al.
I have a question. So if you go back to right, thank you. So here and I'm trying to understand this concept. The graph on the left has
Mm-hmm.
the shortest standard deviation.
Mm-hmm.
Because it has the shortest,
Smallest, not shortest, smallest.
right, smallest standard deviation. Thank you. Would that also indicate that their variance is also the smallest?
Mm-hmm.
Okay, cool.
Yep.
I just wanted to know if one correlates
And
with
fewer,
the
if any, outliers, right?
correct.
Yeah.
All right. All right, cool, cool. All right, thank you. Bye.
The flatter the distribution, okay? Meaning lower numbers, lower counts, if you will, of the different possible data points, the greater the variation, the wider the spread. Okay? The skinnier and taller the distribution, the higher counts of a smaller number of data points. Okay? Other questions? All right. You can compute ANOVA by hand, but I would never make you do that. With experimental designs, the sample size in theory must be equal. However, the ANOVA does have a number of different tests, and you choose the test, which I will show you, based on whether or not you have equal sample sizes. Okay? Regression analysis compares a similar thing to an ANOVA, right? Because an ANOVA is essentially telling you what is the effect of being in one group versus the other on the mean. The ANOVA basically, it's the same thing as dummy regression. Okay? What's a dummy variable again? Who remembers?
What's the what? I'm sorry, you broke off there.
What's a dummy variable? Sorry, guys.
We did that on lab one.
Melissa.
I might not be explaining it correctly, but from the lab, when we created the dummy variable for males, because we were trying to recode it um, to 0 and 1 rather than the data set already having it as 1 or 2. So that way we can compare if the data set is actually something about a 0, like if the data set actually matches up.
Well, let's go. You use the male dummy variable, right? The dummy variable for male is coded, as you correctly said, as 0 or 1. What does a 1 represent?
Male,
And what does a 0 represent?
female.
Well, in the
Well,
NLSY data set, it represents female because there's only males and females, but it could also, in theory, represent not male. Okay? A dummy variable is sometimes also called a binary variable, meaning there's only two possible responses. Okay? And it's coded as 0 or 1 because the variable represents being something, doing something, having something, exposure to something, versus not being something, not doing something, not having something, or not being exposed to it.
old,
Melissa.
old school computer binary code.
Yes, exactly. I
Uh,
mean, all computer code is based on the binary. Yeah, Melissa.
I understood the concept in relation to the assignment, but I didn't understand why it was necessary to create a dummy if the male and female were already identified as like one and two.
So in theory it wasn't necessary, but in practice you need to learn how to create dummy variables for quantitative analysis because for t-tests, you might need to like shrink a variable down to that. For regression analysis, if for example you were going to control for gender, control for race, you would need the dummy variable. So ANOVA can
So,
do the same thing as regression, which I just said. In the ANOVA, you can enter whatever the categorical or ordinal grouping variable is, right? In ANOVA, you could just put in whatever your variable measuring racial and ethnic identity is, which could have infinite number of categories, right? Depending on what people identify as. In a regression model, you can't put a categorical variable in a model. You need to create dummy variables from that. Okay. And you need to create a reference category so you know what the finding is in reference to, right? So if in fact you had a data set where all the respondents fell into binary gender identities, male and female, you would have a dummy variable for male. And in a regression model, whatever the statistic associated with male is telling you what the impact of being male is on the dependent variable relative to female. So if the statistic for the male variable was positive, whatever that dependent variable is, it means it's higher for males than females. If it's negative, it means it's lower for males than females. So using that logic, if I were doing a regression model predicting income in the United States and I had a dummy variable for male, do we think that the statistic associated with male, showing the effect of being male versus female on income, do we think it would be positive or negative? If you compare on average male income in the United States to female income, whose is higher?
Male.
So would the statistic be positive or negative? Thank you, Angela. Positive. Men make more money. I believe it's 83 cents on the dollar still,
So, yeah, right, correct.
which no offense, Al, is garbage, but
It
true.
shouldn't be, it shouldn't be.
Thank you.
Yeah.
So, or another example, if you had a control for race and you had income and you had white versus non-white, would the on income again, would the statistic be positive or negative?
Well, for white people, it would be positive, right?
If it was white versus everybody else, it would be positive. If it was white versus black, it would be positive. If it was white versus Hispanic, it would be positive. What's the one exception?
Asian.
Yes. If it's white versus Asian American, it would be negative.
That's a good
Really?
one. Rich
Which
Asian.
is why I take issue with research on certain socio-demographic outcomes that lump all non-white respondents with each other. Okay. Also worth noting, within Asian Americans, there is a great deal of variation, right? South Asian Americans, Korean, Japanese, Chinese look very differently socio-demographically than Southeast
Asian.
Asians,
Hmm.
Filipino, Vietnamese, etc. Okay. Have any of you guys heard about the model minority hypothesis or the model minority stereotype?
Yes.
Right?
What is that, like a
It's
white man's burden kind of version?
No,
no.
Asian. Isn't
Say more, Rhonda.
it's the model minority is supposed to be the Asian population. I don't know if they specific within that category, but
So the
that's
initial theory was not. It was rooted in a pan-Asian
Mm.
identity that lumped all Asian immigrants and multiple subsequent generations of Asian Americans together as the model minority because of academic performance and attainment. But in fact, it's not true because not all Asian American sub-ethnic groups experience the same kind of academic achievement, educational attainment, and occupational success in the United States, and it is heavily dependent on which Asian country you come from. Vietnamese Americans historically have not experienced the same kind of academic success, the same kind of occupational success as Chinese, Korean, Japanese, and even Indian Americans, right? So it's not used anymore. And there's actually a number of studies in the 90s and the early 2000s that debunked and started to focus on the model minority myth. Okay, so do we get the dummy variable? Do we get the nuanced difference between the t-test, which just compares Al, because Christian's not here anymore, to the rest of us, versus the ANOVA, which for a second, believe me, because I'm going to pretend there's a third group, which would look at me versus Angela versus Rhonda versus Liliana versus Melissa versus Verna, in addition to looking at the comparison of all of us in the aggregate against Al. Does that make sense?
How about those that don't wear glasses?
We could do those who don't wear glasses if you want.
I'm the only one that doesn't wear
Are you
glasses.
really No, Verna doesn't have glasses.
Verna doesn't wear. I don't think.
She's wearing glasses now, Verna. Oh, well,
I too am blind. I wear glasses as well.
Oh, in my mind, you don't have glasses on. Do you have contacts in?
No, I'm not wearing them at this moment. My glasses are for distance, so I don't
I
need
was
them.
like, just to be
don't
clear.
worry. I'm gonna be assimilated at the end of this year. I'll join the
Okay.
glass.
But if you need to
All right.
see them, here we are.
Oh, there you go. All right. Let us return to the ANOVA. Okay. So the F ratio or the F statistic measures again whether the means of different samples are significantly similar or different, right? So if you have a lower F ratio, it means the more similar the samples will be. In that case, you can reject the null hypothesis. If you have your F stat is looking at your between group variability to your within group variability. So again, you're measuring the ratio of difference, which is just another word for variance, looking at the individual groups to each other versus the differences within the groups themselves. Okay? So it kind of looks at both. So as this is, there's these three distributions. It's looking at comparing the mean straight down the middle, right? The orange line, the blue line, the green line. Those three means to each other. That's your between group variance, as well as the within group variance. Okay, so it's looking at differences within the group to differences across the groups. So we are examining the ratio of difference from treatment to variances from individual differences. So if you're comparing by race ethnicity, the treatment is your different racial and ethnic identities, and it is comparing the different racial and ethnic groups to each other as well as comparing all white people to each other, all Hispanic people to each other, all African American people to each other. If the ratio is large, then there is an impact from the treatment. So if the ratio is large, if you're doing an ANOVA by race, then that means that the racial groups are significantly different from each other. Okay? You know it's large enough by looking at what we call the MSE, which I'll show you in a second, and the F test itself. You will get a significance level in an ANOVA as well. Okay. You're able to compare more than two groups. You're able to understand if there are differences in the way groups are treated versus differences within the groups. In an ANOVA, whatever your question is that you're using an ANOVA to answer, the null hypothesis, H0, is that there's no difference. The alternative or the research hypothesis is that there are differences. Okay. So let us go. I tied you guys for a second. All right. In SPSS output, okay, again, we're comparing the means of one or more groups based on some independent variable or factor variable. In a t-test, it's called a grouping variable. In an ANOVA, it's called a factor variable. Okay. ANOVAs do assume normal enough distribution. The null hypothesis is always that there are no significant differences between groups, and the alternate or research hypothesis is that there is. There's a one-way ANOVA when you're just looking at the effect of one factor, one independent variable on a dependent. There's also two-way ANOVAs when you look at the effects of two independent variables. We're just going to look at one-way ANOVAs today. Okay. In a one-way ANOVA, we're going to look at family income by race. If you were to use a syntax file, this is what the code would look like, but we will be using the drop-down menus. Okay. Like all our analysis thus far, in SPSS, we do analyze, we do general linear models, and we go to univariate. Okay. The dependent variable we're going to be using today is income. And the dependent variable is going to be called the race. It's the race ethnicity variable, and it's called key race. We are interested in understanding if wages vary by race ethnicity and whether or not that variation is based on overall trends across the groups, right? Or if there's differences within specific groups. Now, remember before I said, ideally, the ANOVA is comparing groups that are equal in size, but that's, unless you do some sort of very controlled experimental design, that's very rare, okay? If you don't have equal numbers in the groups, the specific test you will invoke to compare those groups to each other is called the Bonferroni test. I will show you all of that in a second. So we're going to, right now, walk through doing this using our NLSY data set. So analyze, general linear model, univariate, like all the stuff we've done before. We get this dialog box. We're going to put our dependent variable in, income, and our fixed factors. So we are trying to compare how average income compares across racial and ethnic groups. Okay. Now, if you were just to click OK from just this point, you would get output telling you whether or not there are between group differences versus within group differences, but you would not get which groups are driving that. So if you want to actually understand which groups are driving that, because there's more than two groups, you want to click on this thing called post hoc. Do we understand why the t-test automatically tells you if it's across the two groups versus the ANOVA you can't decipher? Because in the t-test, you're only comparing two groups to each other. So if there are group differences, the t-test tells you that. In the ANOVA, there's three groups or more compared to each other, right? So if you don't do that additional set of tests, you don't know if it's that Black income versus white income versus Hispanic income are all different from each other, or if it's really Black versus white driving the difference. Okay? If you just click OK at that point, you get an F stat, but you don't get the additional tests comparing the subgroups to each other, and you want that additional information. Okay, so we click post hoc, and you want, so the factor variable here, this is our race variable. It will be in the factor box, and you would move it over to the post hoc test. As I said, general rule, if there are equal number of cases in each group, 20 people in each group, you would pick Tukey or Tukey's B. If you have unequal numbers and they are like disparate, which you'll see in a second in this data set, you would go for Bonferroni because it basically adjusts for that inequality so that the group that has the largest amount isn't driving all of the results. Okay. I also recommend that you click options because then you can also have it generate a descriptives table that gives you the actual means for each of the groups, okay? If you don't click options, you will get an F stat and the Bonferroni stats, which tell you the difference between the groups, but it doesn't give you the actual means. So you would click options, descriptives, continue, and go back to okay, and you end up with this. So the top table is a simple descriptives table. It is telling you the average family income in 2009. Here's our dependent variable, broken down by racial and ethnic group. The top table is simply giving you the mean, the standard deviation, and the N. Okay, based on this table, which group makes the most money?
Non-Black, non-Hispanic.
Non-Black, non-Hispanic. Which group makes the least amount of money?
Surprise, Black. What a
What do
surprise.
we notice about the sample sizes?
Um,
They're not even.
they're different. They're wide
They're
ranging.
nowhere near different. The mixed race group is less than 100. It's 51 respondents. The non-Black, non-Hispanic group is 2,700. The next highest group is almost half that. Is more than half that, I should say. Okay? So you want that Bonferroni test because you don't want the non-Black, non-Hispanic group to drive everything, and you don't want to basically hide the N equals 51 group. You want them to be included in the comparison. Okay, so what you want to look at here, so the F-stat, the test of between subject effects. So the F-stat is telling you if there are differences in income between these groups. You want to look at the intercept model is the empty model, right? It's looking at average difference, the ratio of difference across everybody, not grouping them into racial and ethnic identities. The R148 2600, that's the label on that race variable. You want to look at that. Ideally, that F and the corrected model F are the same. They sometimes are a little different. It's just an extra set of iterations. Okay. Now, based on the F stat, which measures the ratio of difference between the groups to the ratio of difference within the groups, are there differences in income between these groups? What is our F stat? What's our F statistic? Verna.
Look, I am unclear. Is it 98.760?
It is 98.76. Yes,
Okay.
you got it.
All
Okay.
right.
Is that statistically significant? I see heads nodding. Good. Rhonda, at what level is it statistically significant?
At what level?
How confident can you be?
Um, where's Melissa's chart? Where is it?
95, 99, or 99.9?
Is it 99.9?
It is 99.9. There are differences across these groups, but we don't know where there are. And that is why we did the post hoc test, because after it does the initial test, it then does an additional set of tests, and you get this bottom chart, which does the multiple comparison. Now, this chart looks a little complicated. All this chart is telling you for each of the four categories on the factor variable, Black, Hispanic, mixed race non-Hispanic, and then non-Black non-Hispanic, it is simply telling you the differences comparing each of those four groups' average income to the other groups. Okay? So let's look at Hispanic because I realize that red box might be blocking the black. Who makes more money on average in this data set? The Hispanic respondents or the black respondents?
I'm sorry, what was the question again?
Who, on average, who makes more money in this data set? The Hispanic respondents or the black respondents?
Hispanic,
How do you know that?
because the number is positive.
Yes, because the Hispanic average income minus the black average income yields a positive number. And if we go back here for a second, we see the Hispanic average income, 85,400 roughly. The black average income, 64,800. All this table, this column here, mean difference is the average of the group in the first column, I, minus the average in the second column, J. Okay? So if you are comparing Hispanics to everybody else, they make more than the black respondents. They make more or less than the mixed race non-Hispanic respondents.
Less.
They make more or less than the non-black, non-Hispanic respondents.
Also less.
Great. Okay. So we see the mean differences. Now the question is, which ones are statistically significant? Which column am I going to look to tell me the answer to that? Say it loud and proud, Melissa.
The third column.
Which is labeled what?
Sig.
Sig. Significance, sig, that's your p-value, guys. Okay? Comparing black income to Hispanic income yields a p-value of what? Top row, sig column. What's the p-value?
0.001.
Less than 0.001, actually.
Less
Good.
than, sorry. Mhm.
Comparing the black average to the mixed race non-Hispanic average. What's the p-value? Rhonda.
Mhm. 0.389.
Is that statistically significant?
No.
No. Would you report that?
Nope.
Nope. Great. Comparing black to non-black, non-Hispanic. Al, what's the p-value?
0.001.
Yes. Is that statistically significant?
Yes, because of the 99.9% accuracy.
Yeah, great job, guys. Okay. Whether the difference between the mean of the category in column I is different than the category in column J is messaged to you via the significance level. All right. And remember, our significance levels are 0.001, 99.9%, 0.01, 99%, 0.05, 95%. Okay. Now, if you recall, this is without those markers so we can see a little bit better. We did find initially, let me go here, sorry, that the FSTAT, the test of between subjects effects, did show fairly large statistically significant differences in income, right? The FSTAT was 98.76 and it was significant at the 0.001 level. Is this difference across the groups being driven by all the groups, or is it driven by some of the groups compared to each other? Go, Melissa.
Some, only because if you're looking at black compared to mixed race in the first, I guess, box,
Yeah,
the significant difference, well, there is no significant difference because it's 0.389.
right.
And
And if
then
we look at the row for mixed race non-Hispanic, is that group's average income contributing to the F stat? Is the differences between that group and the other three groups contributing to the significant and large F stat? No, how do you know that, Al?
Because of the decimal points.
Yes,
Numbers
because
are
the
large.
significance isn't there. There's no statistical significance. Now, let's go back here for one sec. Given the descriptive statistics table at the top, does that surprise you?
Oh, because of the sample
Yes,
size.
the Bonferroni adjusts, but this may be too much difference in size. Okay? It adjusts so that you're making a fair comparison between the roughly 2,700 non-Black, non-Hispanic and the roughly 1,200 and 1,500 Hispanic and Black groups. But that 2,700 versus 51, right? It's not a valid comparison. Yes, Al.
So just by looking at the descriptive statistics table on the top, we could be led on the wrong path just by looking at the non-black because of the higher population. And we might say the wrong answer by stating, oh, it's a larger group, thus it does have income and income
Well,
impact, right?
so if, yeah, impact. If you were simply saying this group makes more, this group makes less, that's fine. But if you're saying that in the United States, there is racial disparity in income, it's not all groups across each other,
Right.
or there's not enough here. So one thing that would come up is in chapter, let's say this was part of your analysis in chapter 4. In chapter 5, in the limitations, you would say one of my racial and ethnic subgroups was really small. Like I can't make a valid comparison. Future research needs to expand the sample,
So that's
right?
why we got to use that Italian um, factor, Barafoni.
Bonferroni. I
Yeah.
wasn't sure where you were going with that there. Yes, the Bonferroni. It was invented by an Italian statistician. Um, the other thing you could do, if in fact, and I don't think that I have not encountered a circumstance where this made sense in ed leadership, but I have encountered a circumstance in sociology, demography, or ethnic studies where this makes sense. If you were really interested in the effect of the racial income or racial wealth gap, and you only got 51 respondents who self-identified as mixed race, what I would recommend you do is randomly select 51 respondents from the other three groups so that you then had fair comparison sizes. Okay. Or significantly shrink down. And there's like calculators that can help you figure this out. But if your purposes were just trying to understand, like how, for example, the racial income gap plays out in higher ed administration, and this is what you got, you could either do omit the mixed race. This is often why and I suspect as you got, yeah, my voice ain't great, but we're gonna make it. I promise you. This is why perhaps you've noticed in your literature reviews when you're looking at studies around the racial achievement gap, whether it's in pre-K 12, higher ed, attainment, etc., Native Americans are often omitted. Why do we think that is?
I'm sorry, could you repeat?
When you look at quantitative studies of racial gaps relative to like pre-K 12 achievement, graduation, post-secondary attainment, income inequality, Native Americans are usually not included. Why is that? The numbers are small. I mean, we decimated them. But the numbers are small. And unless you're looking at specific regions of the United States, sometimes there's zero. I told you guys the New Jersey DOE massive fail a couple years ago. Did I tell you guys this story? if I did, stop me. Um, During my postdoc, I was trying to analyze some outcomes using the 2018 New Jersey public school enrollment reports, which then had like certain outcomes attached to it, like chronic absenteeism, discipline rates, per pupil expenditures, things like that. And as a comparison, because New Jersey's quite a diverse state in terms of like composition, diversity of communities, district sizes. You got big cities, you got tiny, you got this stuff down the shore, which is weird because these districts only have like pre-K fourth grade because it's people don't live there all year round. And I was looking at Bergen County, which is, if you don't know, the county right over the George Washington Bridge. And I was looking at the differences in average GPA by racial and ethnic group. And not only were the numbers for Native Americans huge, but the average GPA was weighted well above a 4.0. And I was like, what? And it was because they had uh, the New Jersey Department of Education had lost their data manager um, for whatever reason, and then not replaced them between 2016 and 2018. So they didn't have anybody in charge of the sub department that was in charge of cleaning the enrollment data. The districts have to report every like October, whatever. And they had mislabeled the columns. And what was supposed to be Asian American was labeled as Native American. And Bergen County has a huge Asian American population. And so if you had used that year's data and not known anything, you would have been like, holy shit, right? Like, what is happening here where we've closed this massive gap? But also, I grew up in New Jersey. There was not a Native American person in the district I grew up in, and I grew up in a super diverse one. If you didn't also know the demographics of New Jersey, you might, and also didn't realize that like the East Coast doesn't have a ton. Um,
So wait,
yes.
you contacted, what did you do? So you had to contact them and let them know if they're a mistake?
So for you, like when you contact them, you go to like a hotline, right? And that wasn't working out so well. So then I had the director at the center that I was a postdoc at, who's much famous and well known, and people know him, contacted a couple superintendents in New Jersey he knew, and they reached out to the DOE and they fixed it. And then they had to issue a report. And at the bottom of the report, it said, "Thank you to a postdoc at Rutgers University," but it didn't say my name, and I was really upset about that. But also, this is indicative of many things that have come because at the federal level, we don't care about data anymore. I'm sure you guys have seen like the EEOC is not going to collect data from corporations anymore. Like, so if you are looking at studies, looking at reports, or potentially interested in using at secondary data from the federal level, we got to be real careful about like how we look at it, and we need to judge the accuracy and validity of it first. Um, like I would not trust the 2020 census numbers. If you wanted to use census data, I would use the American Community Survey, which is the annual sub sample of a representative smaller group of Americans. It's still got hundreds of thousands of people. It's got actually 1 million plus people in it, but it's not the full decennial census because the 2016 Trump administration gutted the budget for outreach, census outreach workers who would basically like go into rural communities, go into dense urban communities with large apartment complexes, knock on doors, make sure elderly people who don't have tablets and phones and computers were being reported in the census, making sure that transient and homeless people were included. I wouldn't trust those numbers at all. Um, so, all right, tirade aside. Do we get an ANOVA? There's two fundamental differences comparing an ANOVA to a t-test. What are they?
Number variable.
Say that, explain that a little more.
Number of variables being compared.
Number of variables being compared?
Well, now
I'm
I'm not.
pretty sure you're right. You're just mislabeling it. Yeah. It's the mean of something broken down by groups. It's the number.
Um, oh, shoot.
You got it, Verna. Take a minute.
I don't know how to word this. Factors? I don't know.
Give me an example. Put it
Um,
in real world context.
um, I know we started off with like males versus females, but within the male group, there may be varying factors.
So the male versus female, how many groups is that?
That's two groups.
Okay. Is that the ANOVA or the t-test?
That would be if we're just doing those two groups, that's a t-test.
Yes. Okay. Versus the
Um,
ANOVA, which would be what?
um, crap. Like, it's in my head and I can't get it out because I remember your explanation.
Look at the screen right now. Could we be grouped?
So we can be grouped, again, male, female, of the females. I guess we're all wearing glasses. I know that was something we talked about earlier, but like different, subcategories. I'm losing myself.
It's okay. You guys know each other well enough to know certain things about our backgrounds. If you were going to compare Liliana, Ron, you're going to group Angela, Liliana,
Oh,
Rhonda.
it could be, different, backgrounds, ethnicities. It could be,
Yes.
uh, income. I don't know, different
Different backgrounds. Well, not income would be the dependent variable. You're there. It would be backgrounds, race, ethnicity, which for
ethnicity.
the ANOVA would be what? You got this, Verna. You're there. Us. Look at us. Liliana Gonzalez, Rhonda,
Oh,
Melissa.
am I just using identifiers now? We got black, white, Hispanic,
And that is how many groups?
that right there would be three.
And is that a t-test or an ANOVA?
That would be an ANOVA.
So what is one of the main differences between a t-test and an ANOVA?
Two groups versus more than two.
You got it.
Okay.
Okay. That is the fundamental primary difference. Okay. Thank you, Verna. Now, somebody else. What is the second fundamental difference in the t-test versus the ANOVA? So you get this. You also get this. What's the fundamental difference? So this tells us the F stat tells me what? You're muted, Angela. I think you're talking to me, I assume. You might be talking to your daughter. What does the F stat tell me in the ANOVA?
Difference between groups.
Difference between groups overall. Then what does this tell me?
If it's significant or not.
If it's significant or not relative to what information? So the F stat here, is it significant?
Yes.
Yes. So there are significant differences between the groups. What does this then tell me?
The significant difference between each group.
whether or not that's driven by group to group comparison or whether that's driven by differences within the group.
Okay.
Okay. You can have an F stat that is statistically significant and then produce this table and nothing is significant. And if that happens, it means that the difference is somewhere inside the groups.
But then wouldn't that be displayed in here since this is like
No,
displaying?
because this is telling you Black versus Hispanic is significant, Black versus non-Black, that group to group, there are differences. You can have an F stat that yields statistical significance because there are differences within the group.
Okay.
Do we get that? Do we need another example?
I get it, but I don't know how, like, I guess how would you verbalize that in a
What you
results
would
section? Like,
likely do if you came up with a statistically significant f-stat. Also, it would likely be not as large, but it could be statistically significant. And then none of the group comparisons yielded anything. I would then go look at the groups and what's the range there. Because it might be that you had like a crazy amount of, if you had like, if Oprah was in the group and then it was like, I mean, this is would never happen, but this is what's coming to mind, right? Let's say you had public school teachers that nested into racial and ethnic groups and you threw Oprah in there. You might not have racial and ethnic differences in income amongst public school teachers, but you throw Oprah in there, there's a lot of variation in that, right? So then I would say look at the descriptives for each group. And if you looked at the average income for the Black group and Oprah's in there and everybody else a public school teacher, that rate, the mean's gonna be high and that range is gonna be huge. Because even though she don't talk show anymore, she got a podcast. Does
okay.
that make sense?
Yeah. Thank you.
Okay. So the main differences are the ANOVA looks at more than two groups, and it also tells you what is driving the difference. Is it across the groups or between the groups, as the ANOVA labels it, or within the groups? Okay. Does that make sense? All right. We got one more very quick thing to do, and then I'm going to go over your final assignment. Um, what I'm going to do right now is I just want to walk you guys through what you would do if you were looking at some regression analysis, okay? I do not expect, after we go through the next set of slides, any of you to walk away and be like, I could run a regression, I got it. That is not the point of this. This is purely to make sure that if you were to pull a regression study, and maybe there's something in there that helps lay the foundation or the purpose of your dissertation, that you would be able to understand what they did and then cite it properly. Okay, so in varying degrees, the time since we last visited this, what's on the screen right now, may have been recent or not so recent. For myself, it was not so recent. All regression is algebra. Eighth grade algebra, ninth grade algebra, it's whenever you took it. It's algebra. Do you guys remember
Is this
y equals
is
mx
this
plus
slow?
b?
My
Slope,
school,
yeah.
yep. My,
Jesus.
yep,
Okay.
yep, yep.
That's all regression is, guys. It's a bunch of slopes and an intercept, right? Remember, B is the y-intercept. When x is 0, where do you remember the graph paper, which I don't even think kids use anymore,
The X
but you would
value
say
is
like,
0.
okay, x is 0. If the intercept is 3, go up 3 boxes. All right, that's your starting point. And then whatever the slope of the line is, rise over run, that's how you plot the graph, right? That's all regression is. It's a slightly different notation, I don't know why, probably because statistics and higher level math is, rooted in Greek letters. M, which was the slope when you were in middle school or high school, rise over run, is now beta. X is still the same. And instead of lowercase b to represent the intercept, it's beta 0. Okay? If you have one variable in your regression model, there's only one X and one beta. If you have 10 variables in your regression model, there are 10 X's and 10 betas. All right? The X's are your independent variables. The regression model tells you for the change every time the independent variable changes, what happens to the dependent variable. So the regression model tells you every time your X changes, what happens to Y. So it tells you the effect of X on Y. Are we cool with that? Rhonda, Liliana, Verna, can I get a nod or thumbs up, something? Do
Input
we get
changes
that?
out. Input changes output.
Input changes output. X's are your cause, Y is your effect. Okay. In the regression model, they're not called slopes, they're called coefficients. Same thing. The numbers by which the variables in equation are affected or multiplied. It's simply the effect of the presence of X or the effect of an increase in X. If the variable is a dummy variable for male, it's the effect of being male. If the variable is how many years of schooling you have, it's the effect for every year increase in your schooling. The y-intercept is the constant value, that's your starting point. The y-intercept in a regression model is the average of the dependent variable in the data set. This is common regression notation. Y, your dependent variable, equals beta naught or beta 0, your intercept, plus your first independent variable times its coefficient, its beta. Your second independent variable times the second coefficient, second beta. Third, dot, dot, dot to n. You can have infinite numbers of variables in your regression model. If you have 100, you have beta 100, x 100. I don't recommend that. This last part represents error. There's always going to be an assumed amount of statistical error in the regression model. Okay. If we were going to look at interpreting the relationship between school district composition, district enrollment, and dropout rates, we would use a regression model predicting the percent of students who drop out of high school. So what's your dropout rate? And we were going to try to predict that based on the percentage of the enrollment in the district that is Asian, Black, or Latinx. What is the dependent variable in this regression model, Rhonda?
Students,
Students who what?
students who drop out of high school.
Thank you very much. Your unit of analysis is students. What are your, first of all, let's start here. Angela, how many independent variables are there? Yes. Liliana, what are the independent variables?
Is it Latin X, Black, and Asian?
Yeah, the percentage of the district enrollment that's Latinx, the percentage that's Black, the percentage that's Asian. Okay? Behind the scenes, you're in SPSS, you run this model, you get this output table. Okay? When you read an article that reports, or a book that reports regression output, they are going to report the standardized coefficients. They are adjusted so you can compare the coefficients to each other. In this case, the variables, the independent variables or predictors are actually all measured on the same scale because it's a percentage 0 to 100. But sometimes you might have some independent variables that are 0 to 100. You might have infinite ones. You might have a dummy variable. So you look at the ones that are adjusted so you compare them. The first thing you want to look at, so you want to look at your beta coefficients. If this was an article, the standardized coefficients would be the one that are reported. If the coefficient is negative, is it increasing the dependent variable or decreasing the dependent variable? I don't know. If the coefficient is negative, the dependent variable goes up or goes down?
Down.
Yes. How do you know that, Verna?
Um, because oh God, you're going to
You're right.
your coefficient is going to precede your slope, so your slope is going to essentially move in a downward motion.
Yeah. And because it's negative, right? If
Because it's
your
negative,
coefficient
yeah.
is positive, your dependent variable is going up.
Yeah.
All right. So that's the first thing. So looking at these coefficients, which variables increase your dropout rate? Which variables decrease your dropout rate?
It looks like Asian American would be decreasing.
Yep. And
Uh,
which ones increase?
African American and Hispanic Latinx.
Great. Okay. So we looked at those to determine which ones are positively affecting the dependent variable, the Y, and which ones are negatively affecting the dependent variable. Now we're going to look at the significance level. Can I report these? Yes. How do I know that?
Because it's less than 0.001
Yeah,
and
it's
the word's
0.
100% confidence.
Now, in your dissertation or in a published piece, you would have the full table. You would have in the table things that are not statistically significant. You're not talking about those things. You're talking about the things that are statistically significant. Okay. So, the interpretation. So we know the more Asian students in the school, the lower the dropout rate. The more African American students in the school, the higher the dropout rate. The more Hispanic students in the school, the higher the dropout rate. Okay? The more detailed interpretation of this, because that's the general trend. For every 1 unit increase on the independent variable, the dependent variable either increases or decreases by that coefficient. So every 1% increase in your Hispanic population does what to your dropout rate? Your dropout rate, we know, goes up. It goes up by a factor of what?
Point 0.070.
Yes, that's your slope, right? Your X variable is the percentage of Hispanic Latinx students in the school. If you're plotting this on that graph paper from back in the day, right? And your student enrollment is 1% Hispanic Latinx, then it's 1 and then times 0.07, right? So for every 1% increase, accordingly, in the Asian student population, the dropout rate goes down by what?
0.144.
Yes. So if you have 1% Asian students enrolled, your dropout rate goes down by 0.14. But if you have 10% of your enrollment is Asian, your dropout rate goes down by what? 0.14? No, Al, what is it?
14.4%.
No, what's 0.14 times 10?
Oh, I'm sorry. It's late. Yeah, so it would be 10 times that amount.
Yes. And what's 1.4? Sorry, what's 0.14 times 10?
1.44.
Thank you. So this looks, you're like, oh, this is tiny. What does this matter? But if you have, there are school districts in states that are 99 plus percent non-white. There are school districts in this state that are 90 plus percent Asian. It's the cumulative effect here. Okay? So if you have 100% of your district is African American, then on average, your dropout rate goes up by 15.7%. Do we, this is how you, so it's simply slope. The beta coefficients are your slopes, right? Your independent variables. Now, if these independent variables were dummy variables, then the effect of that variable is whatever the coefficient is. If you're male and the coefficient is negative 0.14, then the effect of being male is negative 0.14.
So, may I ask a question?
Yeah, please.
So in Manhattan, a couple of years ago, they wanted to eliminate exams for charter schools or something like that. And I know this is gonna sound kind of racist. Asians were up in like really challenging that because they didn't want Black and Hispanic students to be in their charter schools because they wouldn't have to take exams.
Yeah,
So,
say
so,
more.
so, so they, so they could look at statistics like this and say, if more Hispanics and Blacks students are in our school, then our,
Well, I would argue that a charter school shouldn't make any use of statistics on traditional pre-K 12 public schools because that's not a fair comparison at all. And also, charter schools are notoriously terrible about reporting their data because oftentimes they are exempt from that. And charter schools also do some real funky stuff with enrollment. Um, but yes, I mean, look, you can use statistics. We still have racial and ethnic achievement gaps. We still have racial and ethnic income. We have a wealth gap. We have an income gap, right? In terms of numbers, right? Disproportionately, certain groups are more likely to have contact with the criminal justice system. Now, all of that is true. Everything I just said is true. If you're trying to actually look at what predicts contact with the criminal justice system, should you just look at the racial identity of the person? What do you think?
mm,
No, right? And also, there are structural factors that play into that. How we socially construct these identities. Who's more likely to be classified as special education? Who is more likely to get pushed out of schools? Who's more likely to get racially profiled, right? There's a number of other factors here. Um, I will say that in on the reverse side of that a little bit, right? In New York City, since you use New York City, they did away with the standardized entrance exam for the elementary school gifted and talented programs because they were finding serious disparities in diversity of enrollment in these schools. So there no longer is a test. Now, part of that disparity came from certain parents and families could prep their kids for the test. Even in pre-K, they were hiring tutors. So if you had more resources and more means, or if you simply had the social and cultural capital to know what might be on that test. So they did away with that. However, there has not been a huge change. Number one, they didn't do away with the legacy factor. So if you apply to a gifted and talented program, which is all by recommendation now, and you have an older sibling who is in that program, which is most likely to happen in elementary school when the grade bands are wider, then you get preference, right? There aren't gifted and talented programs at all schools. So if you don't have one near you, you gotta commute to it, and that's also a pain in the ass, right? Which again leads me, great to do away with the test. We should do away with the gifted and talented program because it's ridiculous. But that doesn't solve the problem alone because it's not simply about that. Standardized assessments are biased, but part of the reason why they are biased is because of all these other inputs and outputs that contribute to this, right? Like none of these things exist in a vacuum. Um, I use more simplified examples here to like get the basics, but certainly like in advanced quant, when we start to learn about regression, one of the important things that we talk about is as you add more variables, what goes away, right? And if you're looking at certain things related to academic outcomes, related to achievement and attainment, once you start controlling for socioeconomic status and certain resources like that, the effect of racial and ethnic identity goes away, right? Um, I think it also, though, that's a good example to just remember, we got to think about the context of all of these things, right? And this is not hard science. We are not working in labs where everything is highly controlled. And that's important. Melissa, let me put it back up for you.
It's
Yeah.
okay. It's
No,
okay.
go ahead.
Al, aka my dad, put it in the chat.
Okay. Okay. So just to give you guys one more example here, right? Let's say you wanted to look at predicting GPA based on how many hours you studied, how many days you went to school, and your parents' level of education, right? So the hours is a raw number. The range was 0 to 21. The days present in the school year ranged from 63 to 100. And then the level of education was not numeric, but ordinal, less than high school, some college, and a bachelor's degree or a grad degree. This is a study of 120 10th graders. Here's your regression output. Okay, so let's first look at this. Your GPA, which independent variables positively impact your GPA? And your independent variables are up, oh, sorry, are up here. Y, dependent variable GPA, independent variable X1, study hours, independent variable X2, attendance, and independent variable X3, parent education level. Which of these three positively impact your GPA, boost your GPA?
Study hours.
Study hours does.
Mm-hmm.
Is it the only one?
It looks like all of them.
All of them. Yes, they're all positive. If they were negative, they would reduce it. Okay. Are they all statistically significant? Check that again, Al.
Well, they're 99%. Oh, right. Yeah. Mm-hmm.
They're not all statistically significant at the same level, but they
Right.
are all statistically significant. At the study hours is at the 99.9.001. Attendance and parent ed are at the 90.05 or 95 level. Melissa.
So would you report, wait, you would report on the p-value and the coefficient or just the coefficient?
I would report the coefficient with the standard error in parentheses, and then I would have a footnote at the bottom of the table that explains my notation, and I would do 1 asterisk for the 0.05 level, 2 asterisks for 0.01, and 3 asterisks for 0.001. You could also just do the 0.05 level. Yeah.
Thank
Okay.
you.
So, Rhonda, for every hour I study, my GPA goes up by what?
0.05.
No, that not 0.05. Look at the standardized.
Oh, 0.45.
Yes. So if I study 1 hour and Al studies 0 hours, and we control for everything else, my GPA is how much higher than Al's? I studied 1 hour, he studied none. What happens to your GPA for every hour, 1 hour you study?
Um,
All right, let's start here. For every hour you study, does your GPA go up or down?
it goes up.
Correct. And it goes up by a factor of what? What's the coefficient?
0.45.
Correct. So if I study for 1 hour and Al studies zero, doesn't study, my GPA is how much higher than his?
0.45.
There you go. Okay. Liliana, if my attendance rate is 10% higher than yours, my GPA is how much higher than yours?
Did you say 10 times or okay, so that
Well,
would
10 times, but what does that equate to? So for every percentage point
it
of
goes up
attendance, what happens to your GPA? It goes up by what factor?
to 0.30?
Correct. So if my attendance rate is 10% higher than yours, my GPA is how much higher than yours?
Is it 10% higher or
It's 10% times,
the 0.30?
which is what?
Uh,
Move the decimal, please.
is it to the right or
Yes,
so it would be
to the right.
0, wait, to the right.
No, to the right. Point to the
Oh,
screen.
oh, this way?
Yeah.
Oh, so to my left. Okay.
Well,
Uh,
No, baby, to your right.
to your right.
to my right?
To your
Yes,
right.
I'm sorry. To your right.
Okay, sorry.
That's okay. That was very confusing, I realized, because the mirror
Yeah,
reflection.
because
So it's one decimal place to the right, right?
that is
Hmm.
correct.
Okay, so it would be 0, wouldn't it be 3? 0.
Yes, it's three. So
Okay.
if you and
Okay.
I study the same amount of time, Liliana, and both our parents have the same level of education, but my attendance rate is 10% higher, my GPA is 3 points higher.
Okay.
Okay?
That makes more sense because I'm like, wait, I had a
No,
more
yeah, okay. That's all the regression model is doing. Okay? It is telling you the factor by which a 1 unit increase in the independent variable changes your dependent variable. So if the beta coefficient, the standardized coefficient, is positive, it is increasing the dependent variable. If it is negative, it is decreasing it. So you're looking at your stuff and you're looking at some study on land grant performance in like Obama versus Trump versus Biden, right? And there's a dummy variable in there that's like Obama versus the other two. And I don't know if this is true at all. And the coefficient is higher. It means that land grant institutions in the Obama years got more money. Okay? I'm gonna just take a wild guess. If the dummy variable is for the Trump administration, I'm gonna guess the coefficient is negative. So land grant institutions got less from 2016 to 2020 and then less again, right? That's all it's telling you. So if it's positive, it's increasing the dependent variable. If it's negative, it's decreasing the independent variable. And the coefficient simply tells you the factor by which that increase or decrease happens. It's just slope. All the regression coefficient is slope. Does
Wait,
that, yeah,
so just clarifying. So the 10% has nothing to do with anything. That was just asking
I
a
was just
question.
saying, yeah.
Okay.
Yeah,
You're giving us the coefficient.
I'm giving you the coefficients. Sometimes if you want to illustrate, and a couple of you are going to go down this path with me, and I'll see you again in the spring. But in particular, as the quant folks around here are small and mighty, if you have a committee and you're trying to help them understand what you did, it's sometimes helpful to put it in practical terms. So let's say this actually was the study that you conducted for a second here, and your average amount of study hours per week for your sample was 10. You would say, like, on average, this means that the GPA goes up by 4.5 points, because that kind of like practical application can be helpful for people who are qual, like many of my colleagues who haven't touched this stuff since they were in their own doctoral programs, which, as you can imagine, for some of them was a really long time ago. Yeah, it's me, Al. I'm the quants. Yeah. So, okay. Questions on this? So, one, I know we went longer than we usually do tonight, and I also know that I went a little nitpicky, but I really feel like you guys got this. Am I totally off?
We
Liliana, how do you feel?
we got this.
I feel okay.
Okay is good. I'll take okay.
A little bit more knowledgeable on like how to navigate things. I'm obviously still probably going to be a little confused. It's a
That's
lot of
fine.
like numbers, not my strong suit,
No, look,
but
as I
I do
said,
feel
right?
like 70-ish%.
So, what you need to do in the next couple weeks aside, because you need to finish the class to get the grade. For most of you, the goal, remember, was to be able to read quant work, assess the quality of it, and decide if you're going to use it. For those of you who are in that bucket, do we feel like we are better than we were 5 weeks ago on that? Yeah, that's
Yeah,
honestly, like, that
yeah.
is the most important thing to me. I fully understand some of you are like, bye, never again, and everything's automated. I don't have to balance my checkbook anymore. Yeah, that's totally fine, you guys. It really is. But as kind of properly trained, high quality, diversified scholars, you still should be able to engage with work across the methodological spectrum. You should be able to anywhere from a year and a half to a year and a half to plus from now, attend each other's final defenses and be like, I know what Al just said. I get that's cool, right? That's all that I'm asking for. The other reason too is that, like, to go back to some of the stuff we've been talking about, and I'll throw something up real quick, and then I promise I will get to the final assignment. Oh, I don't want to share files with you guys. But what I do want to show you is this. Had we had time, which we didn't, which is totally fine, I was going to walk you guys through some visual stuff, right? Here we go. Because, for example, do we see this? This is an actual Fox News infographic from 2012. Is this a good infographic?
No,
Why not?
because it's first of all, it should only be 100. Like
It's a
why?
it's a pie
It's
chart.
a pie chart. Who did
It's a
this?
pie chart. A pie chart is a pie chart. The whole circle, the pie is 100%. You got 8 slices, you take one slice out, you got 7/8. You take 4 slices out, you got 4/8, one half, 50%. It's a pie chart. Okay? It's fine that the question was, would you back the candidate, right? Because it's Fox and they want to know, or is our guy getting in, right? Or guy or girl at this point in time. Apologies. Right? So it should have been this. 70% said they back Palin, a little 62% said Huckabee, and 60% said Romney. One, this is accurate. Two, it gives you a better visual to see that it is Palin more, but it's negligible, the difference here. Okay? It's not a pie chart has to equal 100%. That's the first thing that drives me nuts. That's bad data presentation.
I still,
Similar.
I still don't understand it with the bar chart because it's not
It's
like
like They asked, like, how many people would you back Palin, yes or no? Would you back Huckabee, yes or no? Would you act Romney, yes or
Also,
no?
the same
Or
group
it
of
was like
people.
check all that apply. And there was probably a list that had a whole bunch more people. I can't remember that far back. Who else was there, right? Like what's happening? Yeah. Now, a much more useful thing would have been like the total number of people who responded and selected Republic like candidates. But the bar graph is fine. Bar graphs don't have to add up to 100%. A stacked bar graph does, but not this, right? And a
Mhm.
pie chart always has to add up to 100%, right? There's no 100 and this is what 130, 193%. I mean, come on now. Now, also this crime data. What is this? What is this? If I'm looking at this, what is my first thought?
How many murders there were?
Oh, wait, the 2009 looks insane, right? I'm looking at this. That blue chart, that blue bar looks way bigger. All right, hold on. Let me adjust the scale,
Mm-hmm.
right? The one on the left is in the 16,000s in increments of 10. The one on the right is in units of 2,000. It's negligible. If you
Yeah.
compared the number of murders in the 2018 to the number in 2019, you did the t-test, they would not be statistically significant. Okay. The other point of this was so that you can see what's good and what's bad. Okay. Because I suspect too in some of your professional spaces, bad data comes up and bad presentation of data comes up. And sometimes it's professional or sometimes it's the way like I get reports from like NYC DOE does these reports all the time on my kids and it looks off and then it's like, wait a second, the scale on the side is in like days rather than school years or weeks, right? Like my daughter's not going to get held back for missing days. Right. So that was my other main point and purpose. Okay. So last but not least, and I should say, Al, my son would appreciate all of those things you just said because he loves him a spaghetti Western. All right. Even though he's 10. So let me get to the end. Where are we going? Home stretch, guys. All right. Final assignment. It is only 15% of your final grade. Okay, I want you guys to remember that. Um, this is based on the surveys you designed and disseminated. If you ask me to disseminate them, I have sent them out. If you want to ask me to disseminate them, I will send them out. Okay. Um, the if you ask me to disseminate them, all that I would ask is that like by the end of the Sunday night, you start checking your numbers. Okay, once you've hit at least 20, because this is a convenient sample, this is not intended to be generalizable. You can export your data. I want you to do the following. I want you to write up an introduction that includes the purpose of your survey. Many of you have already drafted this in the introduction. You can copy and paste it. What are the questions you're trying to answer? If your survey has sections, which all of your survey has at least two because it's got demographics, right? What are they? And what platform did you program it in? Okay. Then I want a sample section. Describe your convenient sample. How many of them are there and who are they? The analytic plan I will give you, it was going to be based on how far we got tonight. I will amend the assignment portal on Brightspace to have the specific things that you will be running. Okay. I will put it in there. The only difference across all of you will really depend on one thing at the end. You will do a means comparison. If it's two groups, it'll be a t-test. If it's more than two groups, it'll be an ANOVA. But other than that, you're all going to generate descriptive statistics, means, and standard deviations where appropriate, frequencies where appropriate. You're going to do measures of central tendency. So you're going to give me the kurtosis, the skewness. You're going to give me two crosstabs and you're going to do correlations. Okay. Uh, as I said, I will give you the analytic plan. You will just say, like, to answer these questions, I will be doing A, B, and C. Then the results. For each piece of your plan, provide a table with findings. Attached to the assignment in Brightspace are sample tables. You can also, if you want, copy and paste, screenshot the tables that are in the SPSS output. Okay? If that's easier, please do that. There's also sample language on Brightspace. Okay? And then a discussion section. What do the results tell you about your questions? And if they don't tell you anything because your sample size is too small, tell me that, right? And then tell me very briefly, if you were to do this again, what might you change? Would you change questions? Would you send it to different people? What? Okay. Questions on this. As I said, the due date for this is 11:59 on August 18th. You can do it as soon as you want, or it's the final countdown. And as I said earlier, I would not prefer it, but if you need the extra time, please get everything to me by 10 a.m. on August 19th so that I can look at it in advance of my noon deadline. And if anybody feels like they need an extra week or an extra 3 months, I don't recommend the 3 months because if you don't use it, you'll lose it. But if anybody wants an extra day, an extra 2 days, I still have to put in the grade deferred. Otherwise, they will default you to an F. And then I have to go through 2 sets of paperwork to change that. And Fs are also just traumatic to have. But whatever people need for help,
So
please.
this is the lab 3, right?
No, that is the final assignment. Lab 3 is based on tonight's work about means comparisons.
Okay.
Okay. And that again has a due date of next week, but turn it in when you want.
Don't sound so happy, Rhonda.
And really, this is all just to give you extra practice, guys. Okay. But I want everybody to know that like the breakdown of what contributes to your grade is broken down in the way that it is because nothing like matters that much. You've all done at least what I've seen from what people have turned in. Everybody has done a good job on the lab so far. They're 15% each. The quant memos are 10% each. The survey itself was 20%, right? Like everybody's surveys, even with like multiple iterations of change, which you didn't get like points docked. If I asked you to fix something, you fixed it, your grade went up, right? So the survey, it's the construction of the survey was worth more than anything else. Okay. And please, though, if you need help, please reach out. I will say I will be on vacation next week because after I take millions of screenshots and submit my tenure app, I am going away. But then I will be back on Saturday, the 8th, and I am happy to meet with anybody, and that gives us 10 days till due dates. But I genuinely and sincerely, no one should stress about this. It ain't that important, guys. Okay, so whatever you need, I am happy to give it to you. And also, though, congrats on ending your first year of your doctoral program, right? You are very close to being a part of 2% of the United States population, because that is the percentage of Americans who have a doctorate degree, and that is extremely impressive. And if you
What's the
happen
confidence level on that?
100%. It's even lower if you are Black or Hispanic. I don't remember the Hispanic one, but the Black rate is roughly 1.5%. So, and you've already done a lot. So you should be impressed with yourselves. And some of you I will see, well, I will see all of you soon. And some of you we will start working together because substantively it makes sense. And some of you we will start working together because methodologically it makes sense. That is just a reminder that I also oversee qual stuff. Yeah, and anything else you guys need, whether it's about this class or just questions about the program. Technically, I am now the director of the program, so please feel free to come to me.
You're the director?
I am the new director of the doctoral program, not to be confused with the chair of the department, but
Nice.
Oh.
I mean, full disclosure,
Ooh.
guys, and I am now stopping the recording.